All right, my friends, let's see how it went for you. Getting started, I will tend to use A to replace lower bounds and B to replace upper bounds. So in this case, we could just rewrite this as the limit as B approaches infinity of the integral from 0 to B of e to the negative x dx. Okay, so following kind of just the order of operations here, working with the innermost grouping symbol, we would do the antiderivative of e to the negative x. We would get the opposite of e to the negative x, and then we're going from 0 to b. Okay, plugging in upper bound and lower bound and subtracting the results leaves us with the limit as b approaches infinity of the opposite of e to the negative b, and then we'd be subtracting a negative. So I'll just say we're adding e to the opposite of 0, or 0. There we go. E to the 0, my friends, is 1. And so we'd be left with the limit as b approaches infinity. And then up to you how you want to finish this out. I personally like to rewrite this first part as maybe like negative 1 over e to the positive b. Totally up to you how you finish this out. For me, it makes it easier if I write it like that for me to figure out what happens to this expression as b approaches infinity. So, e is 2.718. You multiply it by itself infinitely many times, you get infinity, and then you're dividing little negative 1 by big infinity. So I hope it makes sense. This entire expression here would approach 0. And so you'd be left with 0 plus 1, aka 1. There we go. Okay, so let's go back up to example 1 and just kind of compare what just happened. So for part A, the area there is infinite, but for part B, the area is exactly 1 square unit. Oops, not units, but unit. There we go. We'll just file that under strange but true. And how come? Well, I hope it makes sense that really it's all about what happens at the tail end, right? And so for part A, your rectangles, the heights were approaching 0, but they just didn't approach 0 fast enough. And then for part B, your heights were approaching 0 at a rate that was so fast that even though you had infinitely many of them to add together, you were still able to get something finite. So there you go. And it all goes back to the theory that we talked about back in section 7.7. All right, my friends, and I think that this is a perfectly fine place to stop for day 1. You could, you kind of get a feel for what improper integrals are. And then in the next part, we'll extend that into some vocabulary and kind of some more complicated and sneaky problems that we can practice. But this is the basics. This is kind of where we're going with it. And so hopefully things are making sense so far. And hopefully you'll ask me questions for the parts that don't. Take care.